Hi guys, welcome to this video on the difference of two squares factoring. So, difference of two squares, the learning targets are you're going to be able to factor quadratics in the form of a squared minus b squared using an easy formula. We're learning this because it saves time. It's a good tool for factoring quadratics. And you know you're successful when you can factor a quadratic like 9x to the second minus 36. So, what is the difference of two squares? Defined, the difference of two squares is exactly what it says it is. It is a quadratic expression with no linear term, so no bx in the middle, and its only two terms are both perfect squares, or they are multiples of, and are subtracted from each other. So a squared minus b squared is equal to a plus b times a minus b. A and b are both real numbers. So factoring with the difference of two squares, it's the same formula in order to factor squares when they are being subtracted from each other. Again, the formula is a to the second minus b to the second turns into, in factored form, a plus b times a minus b. So be careful though. The formula listed here does not work for the following setup, a squared plus b squared. It is not true that a squared plus b squared equals a plus b times a plus b. If you were to actually FOIL this out, a squared plus b squared, it will factor into the following. It will be a squared plus 2ab plus b squared. If you were to actually FOIL this half out here, this is what it turns into. And they are not equal. So be careful, all right? These two things multiplied together do not equal a squared plus b squared, and a squared plus b squared backwards is not this. So they cannot be factored back and forth, so just be careful. All right, so let's do some quick examples. Factor x squared minus 9. So what I am going to do is use some recognition skills here and realize that x squared, that's already a square here. So this is a square. It's x times x. And 9 is also a square. And it's 3 times 3. So I can see that there's a square minus a square. So I can factor it into the following. I can factor it into x plus 3. I don't like that parentheses. I'm going to fix it. Don't like that one either. There we go. Times x minus 3. So, because I can see an x here, a 3 here, an x and a 3, that's where the x and the 3's come from in my parentheses. And we have factored form right here. So factor x squared minus 64. Again, I'm going to do some recognition. I know that x squared is already a square, and I know that 64 is also a square. I know 64 can be expressed as 8 squared. I'm going to rewrite my 8 there. So I've got x squared minus 8 squared, and so I can factor it into x plus 8 times x minus 8. So it's pretty easy to remember. It's just that when you start throwing in a couple other things, it becomes a little more complicated. So let's take a look at a little more complicated example. So I have 36x to the second minus 9. So this is what I was talking about when it gets a little more complicated. So we don't have just a variable out front. We have a coefficient times the variable minus a number. So this formula can still work for any case where we have a coefficient as long as this coefficient, so as long as this coefficient is a square as well. If this is a square number, then the difference of two squares will still work. So I'm going to do some recognition, and I know that this is a square. It's 6 times 6. So I have 6 times 6, x squared. I know that's a square. And I know that 9 is 3 squared. So when I factor this, what's going to happen is I'm going to take the square root of 36 to be 6, 6x plus 3. And then on the end, in the second one, again, it's going to be 6x because the square root of 36 is 6. The square root of x squared is x. And then it's going to be negative 3 in the parentheses. So that takes care of the more complicated example. All right, here is where things really get a monkey wrench in them. So 5x to the second minus 45. Well, I know that 5 and 45 are not perfect squares at all, but I'm not ruling out using perfect squares yet because perhaps I can remove a greatest common factor first. So let's see. So if I look at the factors of 5 and 45, I know 5 is prime. 1 times 5 and 45, 1 times 45, but 5 times 9 as well. So 5 is in fact the greatest common factor. So I'm actually going to have to erase that. I will put 5 on the outside of my parentheses. And then on the inside, I remove the 5 from there, so x squared. And this right here, this is a perfect square. I'm going to put PS up here to indicate that's a perfect square. And then the number that was paired with 5 was a 9. So a 9 gets left over from the GCF factoring. And 9 is also a perfect square. So now that I have factored 5x squared minus 45 into 5 times x squared minus 9, I am allowed to then do this right here. We've seen this expression before. I can do the difference of two squares here. So I will factor it into, so I'm just going to factor the inside of the 5 is going to get left alone. And I've seen how x squared minus 9 breaks down. So it'll be 5 times x squared. Oh, not x squared on the inside, excuse me. 5 times x plus 3. And then x minus 3. And that is fully factored. So 5x to the second minus 45 turns into 5x to the third, or excuse me, 5 times x plus 3 times x minus 3. And finally, factor and solve. This one doesn't look at all like any of the ones that we've seen thus far. However, we don't have to discount difference of two squares until if the GCF factoring fails and we cannot see that they're perfect squares, then we have to give up and say, nope, it's not a perfect, or neither of these are perfect squares and cannot be factored to be them. So let's see. What are the greatest common factors here? So I'm going to look at 63. I get 1 times 63, and then 7 times 9. Those are the only factors of 63. I have a minus sign and 1 times 7, and then x times x. Well, I see that 7 is the greatest common factor, so I'm going to factor it out. So I'm going to rewrite this. I'm going to rewrite this in factored form, so it'd be 7 times. Now, if I take out a 7 out of 63, I get 9. If I take the 7 out here, and it is only a 7, okay, because here's it is only a 7. The x's cannot be factored out, just the 7. I would just get x squared. And that's equal to 0. So now I see that I can factor this. This is a perfect square here. 9 is a perfect square. And x squared is also a perfect square. So I can factor this, even though it's backwards, and it's not x squared minus 9, it's 9 minus x squared. Both of these are still perfect squares. They're both still being subtracted, so I can still factor it. So on the inside, take the square root of this, 3 minus x, and then the other one would factor as 3 plus x equals 0. Now, the solve part right here is where I see it's equal to 0. So this is where the zero product property is going to kick in. So zero product property. And the zero product property says that all three of these things, since they're being multiplied by each other, they either all equal 0 at some point, or they are all 0. So we can say that 7 equals 0, or 3 minus x equals 0, or 3 plus x equals 0. So 7 minus 0, that's obviously not true, or 7 equals 0. So we're going to just discount that statement. So let's focus on these two. So what we're going to do is if we can just add x to the other side, then it leaves the 3 all by itself. So I get 3 equals x. I'm going to add x to both sides here. Plus x and plus x. Boom, 3 equals x. And then this one, x is already positive, so let's leave it alone. Just take away 3 from both sides, and we get x equals negative 3. So the two answers for this are x equals 3 or x equals negative 3. So the intercepts of this quadratic equation would be negative 3, 0, and 3, 0. And that's it. That's how you would factor and solve this quadratic equation. So in summary, guys, the difference of squares is a new tool for us when it comes to factoring quadratic expressions and equations. It always follows the same formula, provided you have two square numbers and variables to start. Or if you can factor them, then you can follow the same formula. By factor, I mean use a GCF. Remember that a squared minus b squared does factor into a plus b times a minus b, but this does not work for a squared plus b squared. They will not factor the same. So that's it, guys. That's the difference of squares. I hope you enjoyed the video, and I will see you in the next one.